These are 4 problems to get you into thinking about activity 2, which is moving towards a more general formula for finding the slope. So this is called a launch, just 4 problems to get you thinking about this. And the first problem, actually for all 4 problems, they ask you to figure out what the slope is of a line that passes through each pair of points. In the first problem, the 2 points are 12, 4, so the x-coordinate is 12, the y-coordinate is 4, and the x-coordinate is 7, the y-coordinate is 1 for the second point. And the slope is 3/5. I'm going to give you the answer, and I want to work from that answer and just say a few things as we develop our thinking about a formula for finding slope. So one of the things that you can say about the 2 points, I'm going to label one point A and one point B, and you can figure out which is which, because the x-coordinate for A, well, actually, first of all, let me remind you that the quadrants of a coordinate axis are labeled in a counterclockwise manner, beginning with quadrant 1, which is when both coordinates are positive, quadrant 2 when x is negative and y is positive, so it goes this way negative and this way positive. Quadrant 3 when both are negative, so this way negative on the x-axis, this way negative on the y-axis. And quadrant 4 when one coordinate is positive, the x-coordinate is positive and the y-coordinate is negative, so this way on the x-axis and this way on the y-axis. So one of the things that you can say about these 2 points is that if the slope is 3/5, for every 5 units of change along the x-axis, there are going to be 3 units of change along the y-axis. And that can be simplified to every unit change along the x-axis, there's a 3/5 of a unit change along the y-axis. Those are the same things because 3 is 3/5 of 5. So 2 units along the x-axis is going to be 2 times 3 or 6/5. 3 units, 9/5. 4 units, 12/5. And 5 units are going to be 15/5. And 15 divided by 5 is in fact that 3. So a couple of things that we can say about the x and y coordinates. So the x-coordinate and the y-coordinate. If you compare them, and I'm going to call, for point A, I'm going to call the x-coordinate x and the y-coordinate y. For B, I'm going to call the x-coordinate x prime and the y-coordinate y prime. So this is moving towards a more general formula that we're going to develop. And one of the things that you can say in the first quadrant, if it's a positive slope, is that the x-coordinate for A in this case is going to be closer to the y-axis than the x prime coordinate for B. And you can just see it, you can look at it and see it. This doesn't go as far, this goes to this point along the x-axis, and B goes farther along the x-axis. So B is farther away from the y-axis than A is from the y-axis. So the y-axis is where they're starting at 0, 0. The other thing I can say is that the y-coordinate for A is closer to the x-axis as you move along the y-axis. So as you go up, moving along the y-axis, you come to A first, and then second is B. So B is farther away, and that gives you a positive slope. So this is going uphill from the left to the right. You're going uphill especially when you're in quadrant 1. Actually, that's true for all the quadrants, positive slope going uphill as you move from the left to the right. And something else you can say is that the difference between them, and this is now getting more and more towards this point of a general slope formula, as you find the difference between them. And so what that means is I'm going to take where I end and I'm going to subtract where I began. And so the y-coordinate, y prime, minus the y-coordinate for A called y, that difference, that length right here is 3 units. And the difference between x prime and x, so I'm going to take x prime and I'm going to subtract away x. That difference is 5 units. So now let's use these numbers and go into this a little bit more detail. So I'm going to end at B and I'm going to start at A. You could start at B and end at A. You could go downhill from the right to the left. You will get the same answer. You have to get the same slope. It's just a little bit easier to calculate if you are going uphill and you look at it as ending at B and beginning at A. So to find the difference, I'm going to take where I ended and I'm going to subtract from that where I start. Now look at this slope triangle. And so what you're going to do first, I'm going to work with the y coordinates first because that's usually what we've done in the past. I'm going to slide the slope triangle down how many units? I'm going to slide it down 1 unit. So this is 3 units plus this 1 unit. So I'm going to slide this down 1 unit to right here. That is that 4 minus 1. And so you figure out that this change is 3 units. So if you start at the x-axis, you're going to go up 3 units and get this amount of change in the y-coordinate. Now what we're going to do is take this slope triangle and slide it to the left. How many units? That's that 7 units. So we're starting at 12, and we're taking off these 7 units, which are right here. So 12 minus 7 is going to slide this point over to the origin, and it's going to be 5 units long. So 12 minus 7 is 5, 4 minus 1 is 3, and the slope is how much the y-coordinate, how much there's a change along the vertical axis or the y-axis for every change along the along the x-axis. So it's 3 units along the y-axis for every 5 units along the x-axis. So that slope is 3/5. And notice that 5 times 3/5 is equal to 3. So 3 is 3/5 of 5. And it's kind of hard to look at without writing it out like we have done in the past. So we'll get there. We'll come back to that. Now, one last thing that you can do with this is actually figure out the equation. If you want to know where this line intercepts the y-axis, where does it cross the y-axis, you can figure out the equation and know this exactly. I had a sense that it is a negative value, but I don't know what it is exactly. So you know how to do that. So the first step is to write, first of all, the slope is 3/5, and to write the change in y over the change in x. So how much is the y along, how much is this triangle changing along the y-axis compared to how much is changing along the x-axis? Now I actually skipped that step and I went to the second step, is that now you can write this y minus 1 is equal to 3/5 times x minus 7. So I just, and we've been doing that in the past, where we take this ratio, y minus 1 to x minus 7 equals 3/5, and that tells you that this change in y is 3/5 of that change in x. So remember that x minus 7 gives you how much this is changing, and 3/5 of that change gives you this change in y. You just have to keep doing this to get used to it. So now the next step is you can, if you have 3/5 times x minus 7, that means you have 3/5 x minus 3/5 times 7. Well, 3/5 of 7 is 21/5. And I want to do this because I want you to continue to try to work with the fractions. Don't change it to a decimal. It's going to be easier if you work with the fractions. So now we have to change this 1 to fifths because everything else is in fifths. Remember, we have to add that 1 back. We have to slide this back up, that 1 unit, to get to this line. Well, if I have to add 1 back, I want to add it back as 5/5. So I'm going to add 5/5, and at the same time, I'm going to subtract this 21/5. Well, 21 minus 5 is 16. So that's going to give me a 16/5. And if I rewrite this, I didn't do it here, I should have. I could rewrite this as 3/5 x plus a negative 16/5. And that negative 16/5 tells you that the y-intercept is a negative 16/5. Well, what is negative 16/5 as a mixed number? Well, 15/5 is 3. We actually saw that up here. 15/5 is 3 plus 1 more fifth. So that's a negative 3 1/5. So this intercept right here is y equals a negative 3 1/5. So this point is 0. It's moving 0 along the x-axis and a negative 3 1/5. So we're going to continue to do this. So let's try this now with the second pair of points. And there, the y-coordinate and the x-coordinate is now a positive x value and a negative y value. So where do you end up in the coordinate plane? You end up in this quadrant number 4. So a positive x value and a negative y value. So you're going to end up somewhere down here. It's still going to be a positive slope. So the line is going to go something like this. And that slope, I believe, is 1. All right, so let's draw that. So this is quadrant number 4 now. Quadrant number 1 was up here. This is 2, this is 3, and this is 4. And in this case, I actually put the points with A and with B because we're working with negative values, a little bit harder to work with. So I want to make that clear. So one of the things that we could say about the slope is that for every unit change along the x-axis, it's the same change along the y-axis. So the change in x is always equal, the change in y is always equal to the change in x. So 1 over 1, 3 over 3, 7 over 7. Goes 7 units along the x-axis, 7 units along the y-axis, 3 units along the x-axis, 3 units along the y-axis. So that ratio, that comparison is always going to be 1. So that's one thing you can say is the slope is 1, so the y change compared to the x change is 1. Slope is positive, so you're moving from the lower left to the upper right. So basically you're going uphill as you move from the left to the right once again. Okay, now watch what happens. A little bit of change here. So you can say that the x-coordinate for A is less than the x-coordinate or x prime for B because it's closer to the y-axis. So if you go along the x-axis here, you reach A first. So that makes A less than B. So now you're going along the x-axis further, you get to B. But watch what happens to the y-coordinates. Now you're going down the y-axis, you get to B first, and then you get to A. Well, this is still less than B. It's more negative. So as you go in the negative direction, the farther you get away from 0, which in this case is the x-axis, the less that value is, the more negative it is. So y is still less than y prime, but it's not closer to the x-axis. It's actually farther from the x-axis because it's moving in the negative direction. So that's something to think about, just getting more and more used to thinking about positive and negative numbers. So the more negative, the lesser the value, the farther from 0. So x is still less than x prime, y is still less than y prime, but now you have to think about that it's moving farther from the x-axis because it's more negative. The difference between y prime and y is equal to the difference between x prime and x. They must be equal because the slope is 1. So when you calculate the change in y, the difference from the difference from the end from the beginning, so you're going to subtract the beginning amount, that value has to be the same as x. So the x value where you end, subtracting the x value from where you start, that has to be the same as the y value where you end, subtracting the y value from where you start. Well, let's do that. See if that works. So I'm going to take where I end, which is 7, negative 8. So you're going to go out here 7 units and down 8 units. And I'm going to subtract from that where I started, which is 4 units and negative 11. So I'm taking where I end. So I'm going to go up. You could do it the opposite way. You could treat this as where you end and this as where you start. But once again, probably easier to think of it as going uphill. So you end here and you start here. So this is 4, negative 11. So I'm going to subtract, I'm going to take this amount away from where I ended, 7, negative 8. All right? So the y values, now look what happens here. I'm taking negative 8 and I'm subtracting negative 11. That is sliding this up 11 units. So now we're going to end up here at positive 3. We're basically taking this slope triangle. If you subtract a negative 11, you can use the inverse operation, addition, and the additive inverse of positive 11. So you're adding 11 units. This is going to end up here at a positive 3. And look what happens now to the x value. So now I'm going to take 7 and I'm going to subtract 4. So I slid this up. And so now this is resting on the x-axis. This slope triangle is resting on the x-axis because we slid it up 11 units. And now we're going to slide it to the left 4 units. So that's going to be this 7 minus this 4. So you're going to take away this amount right here and slide this over to the origin. So the change in the y value is positive 3. The change in the x value is positive 3. That ratio gives you a ratio of 1. So you just have to continue to go through this, and that's the whole idea of this lesson, is to begin to develop this formula for calculating slope. Now let's add to this, let's calculate where this crosses the y-intercept. And again, you know how to do this. I'm going to treat this as x and y, so it's going to be y minus a negative 11 over x minus 4, because that's what we did. We took the y value, we subtracted negative 11, and we took the x value and we subtracted 4. Oh, actually, let me show you right here. This is negative 8 minus negative 11. So you can use the inverse operation, which is addition. So you can change this operation to addition. If you do that, you also have to use the additive inverse. It has to be the inverse and the inverse. It has to be the inverse operation and the additive inverse. So I'm going to take, subtract negative 11. That's the same as adding positive 11. And then it gets a little bit harder when you work with negative numbers. You have to remember that you have to find the difference or subtract their absolute values. So this is 11 things, 11 positives. And this is 8 things, 8 negatives. Well, the absolute value is 8 and the absolute value is 11. It's the number of things. Forget the sign, it's just the number of things you can count. 11 minus 8 is 3. And this is going to take a positive sign because you have more positives. So this is going to be a positive 3. Okay, let's use that idea and write the equation. So here's the y minus negative 11. So it's this y minus negative 11. So it gets easier as you're doing this stuff. It's going to equal 1 times x minus negative 4, x minus negative 4. So I'm skipping the step where I'm writing this as a ratio, y minus negative 11 over x minus 1, because then I can say what that equals 1. What that says is that y minus negative 11 is equal to 1 times x minus 4. Well, 1 times x minus 4 is x minus 4. So now we have y minus negative 11 equals x minus 4. So if we subtracted this negative 11, we have to add that negative 11 back. So we have to slide this triangle back down here by adding negative 11. So I'm going to add negative 11, and at the same time, I'm going to add negative 4. So I'm going to change this to x plus negative 4. I actually didn't write that here. I should have. At the same time, you have to add negative 4. So I'm going to add negative 11, and I'm going to also add this. This is going to become negative 4. I hope you understand that. Should have written that out. X plus a negative 4. Well, negative 11 plus negative 4 is equal to negative 15. And I kind of messed this up, and I should have written that step in here. The problem is if you write every single little thing, man, it gets long. So I just leave it at this. So this turns into x minus 15, which is the same as x plus negative 15. And maybe from this you can see the negative 11. So you're going to add negative 11 to negative 4. and that gives you negative 15. So this intercept right here, the reason I want to rewrite it as x plus negative 15 is that intercept is, in fact, negative 15. So this is getting you this, and you know how to do this. We've done this a whole bunch of times, just reminding you how we did it. All right, the next problem. This is back to the first quadrant, because both of these, the x and the y values in both cases are positive. But man, look at this x value. This is 600. And so the slope turns out to be 1 over 599. Well, that looks tough. We have to deal with that a little bit. So what this means is for every 599 units of change along the x-axis, you have to go out here 599 units. It's one change along the y-axis. So that's a really, 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 really shallow slope, or a really small slant in the line. So that picture might look like this. I couldn't really even get it on the page very well because I have to go out here 599 units and just go up 1. So I tried to put this as close as I could and as small as I could so you could still see it, to give you the idea that you're going out here 599 units and up just 1 unit. So that's a slope of 1 over 599. All right, so this goes back to what we did before. The x value for A is closer to the y-axis, so you reach A first as you go along the x-axis, and then B. So x is less than x prime goes with B, and y is less than y prime. So as you go up the y-axis, you hit A first, and then B. So this is the same as before. And the difference, where you end up, and you're going to subtract where you start, the difference in the y values is going to be just this 1 unit here. But the difference in the x values is huge. It's 599 units. So it's where you end up, subtracting where you started, and you're going to end up with an answer of 599. All right, so let's use the numbers and calculate the slope. So the y value is 3 minus 2. So it's that 3 minus that 2. So you're going to subtract 2 units. And so you're going to slide this slope triangle down 2 units. And you really can't see that. I should have moved this out here farther so you could see it sliding down 2 units. But this tells you that it's sliding down 2 units. You're ending up now right on the x-axis, and this changes that 1 unit. And then what are you going to do? You're going to take this slope triangle and slide it over how many units? Just 1 unit. Slide it over just 1 unit. So that's going to make this change, 600 minus 1, it's going to make this change 599 units. So what's the slope? So the slope is how much the vertical direction change, 1 unit, compared to the number of units that the x value changed along the horizontal axis. That was 599 units. So the slope is 1 over 599. Now this gets a little bit complicated if you're not comfortable working with fractions. I'm going to go through this with fractions. I'm going to look at the formula using the fractions. I just want you to go through it, continue to persevere, work through it. Don't give up. Think about how the fractions work into this. All right, so y minus x, y minus y prime minus y, So this is y minus that 2, y minus that 2. That's equal to the slope, 1 over 599 times x minus that 1. So it's this x minus that 1. Now again, I could have started off writing y minus 2 over x minus 1. That equals 1 over 599. What that means is that y minus 2 is 1 over 599, or 1/599ths of x minus 1. All right. So it's this 1, that's this This change right here is just 1/599th of this change. All right, so now I want to, this is using the distributive property. So this is, if I have 1/599th x minus 1, that means I have 1/599th x minus 1/599th, because this 1 times 1/599th is 1/599th. All right, it's not that bad if you keep trying to do it. All right, so how many 599ths is 2? Well, it's 2 times 599, because I want to write this 2 with the denominator of 599, because that's what everything else is. That's the common denominator. Well, 2 times 599 is 1,198. So this equals 2. So just hang in there. Keep thinking about it. So this is y minus 2, or y minus 1,198 over 599. So that equals what we wrote down here, 1 over 599 times x minus 1 over 599. So now, if I had subtracted this 2 to get to this x-axis, I have to add that 2 back. So I have to add 1,198 over 599. I have to add that back. And at the same time, I have to subtract 1 over 599. So I have to take 1 and subtract it from 1,198. That equals 1,197 over 599. Well, that looks tough. That looks tough. You could test it by plugging in a value for x. Let's just plug in 1 for x. 1 times 1 over 599 is 1 over 599. Add that 1 to 1,197. That gives you 1,198 over 599. What was this equal to? That was equal to y is 2. So if you plug in 1 for x, you get out y equals 2. If you plug in 600 for x, you get y equals 3. Because now you're going to end up adding another 600 over 599ths. I'm not going to go through that. You might go through that on your own. See if you can get y equal to 3 if you replace x with the value of 600. It's going to be 600 over 599. You're going to add that to 1,197. Well, 600 is 1 more than 599. 1,197 is 1 less than 2. So this is 1 more. This is 1 less. So you add those 2 together, it's going to be 3. It's the value you're going to get at the end is going to be a value of 3 whole units. So you might go through that on your own. All right, the last problem is this 3740 and 3033, and the slope again is 1. So as before, so this is in the first quadrant once again, and as before, the move along the x-axis means that the change in the y-axis is going to be the same because the slope is 1. So all of this is the same as before. When you move along the x-axis, you get to a first. So x is less than x prime. When you move along the y-axis, you get to a first. So y is less than y prime. And the difference between y prime and y is 7 units. So this length right here is 7 units. And it's the same as the difference between x prime and x, 7 units. So these have to be the same. So hopefully you're getting used to this. If I now calculate that change, I'm going to take the values where I end up, and I end up at 3740. So this is the one that's farther out. This is x prime and y prime, and I started at 3033. So this is a is the one that's closer. So I'm going to subtract from where I started from where I ended. So this is 37 minus 30 is that 7 units. And this is 40 minus 33 is that 7 units. and 7 divided by 7 gives you a slope of 1. All right, the equation, a little bit easier for this one. So if you replace the 40 with y, this is y minus 33. So what are you doing? You're moving the slope triangle down 33 units. So y minus 33, and you're going to now subtract 30 from the x coordinate. So you're going to slide this over 30 units this way. So it's taking away this part right here, sliding it over 30 units. You're ending up right there. So y minus 33 over x minus 30 is the same as y minus 33 equals 1 times x minus 30. They're equal. Remember that the change in y has to be equal to the change in x. So the change in y has to equal the change in x. So 1 times x minus 30 is x minus 30. So these two are equal. They have to be equal. This is the change in y. This is the change in x. All right, if I subtracted 33 to slide this down, I have to add that 33 back. At the same time, I have to subtract this 30 right here. So I'm adding 33, I'm subtracting 30. So what's that equal? It equals x plus 3. So where does this cross the y-axis? It crosses the y-axis at 3. So this one, if you replace, let's say that you use an x value of 37, place x with 37. What's 37 plus 3? That is that 40. Let's say you replace x with 30. X with 30. What's 30 plus 3? It is that 33 right there. So the equation works. All right, so it's a long launch, but there's a lot of stuff there, which if you're following it and if you practice it on your own, then the actual activity will become really quite easy. And we're going to get to that next.